Hi, everyone. Today, we're very happy to have with us Olga Russakovsky, professor at Princeton. Olga did her PhD at Stanford, working with Fei Li. And from there, went to do a postdoc at CMU and became professor at Princeton. Olga, it's really great to have you. How are you doing?
Thanks so much for having me. I'm doing well. I'm excited to be here.
Yeah, we're very excited too. So one of the main things you're famous for is that the fact that the data on which AI is trained can really affect the outcome, the decisions the AI is making, and that there can be bias in the data. What does that even mean for it to be bias in the data and in AI systems as a consequence? What's the issue here that's at stake?
There's always bias in the data, right? So what is at stake? So what's at stake is the following: we're building these systems that are, in theory, we sort of say, this is an automated system. It's making automated decisions about the world, and that in some ways implies that this system is impartial. This is kind of a almost an underlying assumption. Okay, the system is fully automated. It's making fully automated decisions. But of course, in practice, the system is actually learning patterns from data that we have provided, which means that if the data has a particular distribution, so for example, if in the computer vision world, right? So supposing we are trying to train a model for recognizing computer monitors, and it turns out that in the data, in the photographs of computer monitors, they primarily co-occur with men and not with women. And so the model may learn that, okay, one way to recognize what a computer monitor looks like is it actually starts looking for, okay, is there a man in the photo? And if so, then the probability that there's a computer monitor here would increase. And so kind of as a result of this kind of pattern in the data, it's learning to make decisions based on features that maybe would be undesirable. Like this is both sort of counter to accuracy of the system. This means that, if this is the kind of pattern that it learns, this is sort of picking up on kind of spurious correlations in the data rather than focusing on the task at hand. And so this harms accuracy of the system. But also, so in computer vision, there is, so computer vision is a space where there is frequently a correct answer to the question. So if I ask you, is there a monitor in the image? There is an answer like, yes, there is a monitor, no, there isn't. But there's a lot of places where AI, sort of automated decision-making is being applied. So this is, for example, within the criminal justice system, within loan prediction or sort of decisions about who to give loans to and things like that. And in those settings, there's no ground truth answer. You're sort of predicting risk. You're predicting, what kind of decision should you make. And they're even more so, it's sort of, first of all, harder to recognize what kind of biases or sort of patterns may be hiding in the historical data. So for example, for loan prediction, you are training a model to to automate prediction that's based on the data that you're feeding it, which tends to be past historical data of sort of who has gotten loans. And so if that past historical data has a particular type of, for example, gender or racial bias, which, surprise, it does. But as soon as that bias is in the data, what's going to happen is that the automatic system, which is basically trained to replicate the past decision-making, is going to then incorporate those factors into its decision-making. And this has, first of all, this now becomes propagated on a much larger scale because these systems are deployed at massive scale and now are making all of these decisions where, one person might make biased decisions, but they're making a relatively small number of decisions, whereas the system can be deployed everywhere. The second thing is, as I've kind of already mentioned, we think of these systems as impartial, and that's just fundamentally not true. And so that's sort of the second negative and the second danger. I would say that on the plus side, though, on the positive side, it's very difficult to get people to make impartial decisions. It's very difficult to sort of get folks to not be swayed or biased by gender, by race, by all kinds of social constructs. But with AI systems, what's really great about this sort of research space is that we can actually do things that make it better. And it's in some ways easier because as soon as we kind of identify a particular bias that the model is exhibiting, okay, we can go back and we can, try to adjust the data. We can get creative with how we adjust the algorithm. We can really rethink the design and would have meaningful kind of immediate impacts. And we don't have to, and the impacts, first of all, become deployed on a very large scale and make things better on a large scale. And second of all, we don't run against sort of issues of people saying, what are you talking about? I'm not racist. Like, why are you accusing me of it? Like the AI systems don't have that kind of reaction. They just get better if we put in the effort to make them better.
Right. So I feel like there is somewhat of a big distinction between some of the problems that you mentioned. So on the one hand, there is computer vision. On the other hand, there is criminal justice data sets and loans. And computer vision, it feels like if your data isn't great, if you can identify that, and that's a big if probably. I mean, your work helps make that happen. But if there is a way to identify it, you can in principle go snap more pictures. But in criminal justice, I mean, obviously you can't just make some arbitrary new decisions to complement your existing data. That doesn't work. So I'm really curious. What can be done if everything comes from the data, but you can't just generate new data because you can't just incarcerate somebody because you need an extra data point. That'd be a crime in itself, obviously. So what are the things that are available to still do something when you cannot just collect more data?
I have so many things to say on this. So first of all, on the computer vision side, I think, in some cases you can go out and snap our photos, but in other cases, actually, it's very difficult. So for example, we're like talking about geographic bias in visual data sets right now, that a lot of the photos come from the web. We tend to sort of download images from the internet, which means that they come from particular countries, from particular regions. And so this question of like geographic bias of how do we make a data set that's more geographically inclusive is very much sort of at the forefront of research right now. And there's like no easy answers to that of like, we have to basically rethink the entire data collection pipeline to do that.
And what's an example of like a bad effect of geographic bias in the data sets?
Yep. So it's been shown in a paper a couple of years ago that the current object detectors that are sort of in theory, generic object detectors, fail to recognize, for example, soap from countries out like bar soap that's not commonly used in the US. So the soap detector ends up being a detector for US brands of liquid soap. And when you show it, photos from other countries where, the majority of the world uses bar soap, it just doesn't recognize it, hasn't seen those photos. So that's one example, but there's many, many others of like different household objects, of different scenes of people, certainly that come as a result of these kinds of geographic biases and imbalances in the data set.
And so going back to the other kind of data, the non-vision data, where it's completely impossible typically to just fabricate more data that's real data. What are some ideas that still can maybe work? Yeah,
so first of all, there's definitely things you can do on the algorithm side. So even though the data has particular, the data is sometimes it is what it is, and even if you can get more data, sometimes it comes from a particular distribution that like represents the world, and you can't invent more. You can't invent more data if there isn't if there isn't sort of enough of a particular type of data. So one of the things you can do is basically on the algorithm side, you can try to impose particular constraints in learning the model that sort of, for example, says things like, I value different errors differently. So I'm trying to train a model to achieve high accuracy in this data set, but I really will, sort of impose a very high cost on making one type of error and a low cost of making another type of error. So the example I commonly give there is with autonomous driving data sets, right? So you have data set of a car driving the world. You will see very, very few examples of accidents, and that's good. And that's, you could try to sort of simulate more, but in practice, it's a very long tail distribution. It's a lot of sort of normal driving scenarios. But you could still learn from this data, and you could tell the model, okay, there's a very, 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 very high negative penalty for doing the wrong thing and like causing an accident. Whereas there's a much smaller penalty for if you sort of, stop the car when it's not a dangerous situation. And so in that way, you're kind of imposing particular, I don't want to use the word values, but kind of particular things that you care about. You can tell the model that at the algorithm level, even if your data has sort of imbalances or biases in it.
So if we can kind of go one step deeper here into some of the specifics. I saw you recently published a paper with a method called Revise. I think that ties into everything we've just been discussing. Can you say a little bit about the ideas behind that work?
Yeah, so Revise was a paper. So it's the lead author is my PhD student, Angelina Wang, and the other co-author is my colleague, Professor Arvind Narayanan. And this is work is a tool that essentially strives to reveal biases in visual data sets. And so what we look at is we take as an input an image data set, so sort of a collection of images and whatever the associated labels are that have been collected on the data, and try to output sort of patterns from the data. So what do we discover? And kind of at the simplest end is things like, this data set has a lot of pictures of cars, but not enough pictures of people. And that's kind of those, and sort of the simplest is just like numbers of different concepts. But you can go deeper at, for example, looking at, what things co-occur together. You could look at things like, maybe coming back to the like monitor or computer example and like people of different genders. You could say, okay, maybe a computer co-occurs with people who likely identify or who identify as female versus people who identify as male. They co-occur in the same frequencies, but maybe one of the genders actually occurs sort of closer to the computer and the other one occurs further in the photo, which suggests that maybe some people are more likely to be interacting with this object as opposed to others. And so the Revise is a tool that tries to kind of bring to light some of these patterns in visual data, and then hopefully inspire the downstream interventions. So either when you're building an algorithm from this data, you can sort of say, okay, I know there's these patterns in the data, but I would like my algorithm to not focus on those patterns. I would like the algorithm to be insensitive to those patterns. Or you can say, okay, these patterns are a little weird. Let me just go collect more images if that's an option that's available. Let me collect more images of maybe don't have these particular patterns that you think are harmful or unnecessary for your downstream application. That's
really cool. And so is it fair to say that if, let's say, I would want to build a computer vision AI system and I have a data set that I plan to use, I can actually pass that data set through Revise and it could expose to me issues with the data and then encourage me to improve my data set or change the way I train on the data set to resolve some of these issues?
Yep, that's what it's intended to do. And we're still working and making it more and more general. And we've, tested, I think, 4 or 5 data sets by now, but are definitely very actively working with actually a large team of students now trying to make it more general as well.
So it seems like something pretty much everybody should be encouraged to use then. If you're going to deploy your AI systems. Yeah. This is great.
That's the hope.
I'm sure it'll happen. So now one thing is bias in data and AI systems making large-scale decisions, but there's another thing that that in some sense is a form of bias, I would say, is if I look at, let's say, the history of deep learning, and I see who is being highlighted. There are iconic figures like Geoff Hinton, Jan LeCun, Yosha Benjo, who keep recurring over and over. And of course, did many amazing things, but there's also something that stands out about them. They're white males, not exactly maybe, as representative of the world as it could be. And I know you've been actually done a lot of thinking about that. And can you say a little bit more about that? And what are some of the issues there, and how can we address them?
Yeah, so thanks so much for asking that question. So we've so far been talking about bias, right, in data, bias in models, but there is a much richer history of sort of structural bias kind of leading into the design of these systems. And here, you can think about things like, what are the applications that we're trying to solve right now with AI? Like, where is the effort going? What are the kinds of questions we're asking, even on the data side, like who defines the type of visual concepts that we are working to recognize? And all of these come down to the question, right, of like, who are the researchers? And are the researchers representative of the population at large? We like to say that, AI will affect everybody and we're building it for the betterment of humanity. But the of course, there's sort of the caveat that if the researchers are not representative of the world at large, then chances are, we're going to bring our own biases to the table. We are going to work on problems that we think are important. We're going to come up with solutions that we think are the right solutions. And if the people at the table are not a diverse group, then inevitably the kind of solutions, the kind of outcomes that result from this are going to affect and benefit people who look like us and who come from similar backgrounds, who have sort of similar needs to us. And so this is why I think, for the health of this field, to make sure that we actually do all the good with AI that we think we can do or that we hope to do, we really need diverse voices at the table. We need people coming from different backgrounds. We need people who read different books as kids. We need people who have different opinions about the world. We need people with sort of different perspectives, with different family structures, with different viewpoints coming together and actually, taking on leadership roles within the space.
So this really resonates, and I really like what you highlight there is that researchers actually choose what problems to work on. It's not that there's this list of things that we all try to resolve, and that's like a ground truth list. We actually, in some sense, make up the problems we research, right? And so I'm curious if you have any examples of research problems that you think have been missed and now are starting to get more attention as we get more diverse representation in our community. Well, we're nowhere where we need to be, but as it's slowly is maybe getting a little bit better. What are some signs there of interesting new problems that we're seeing cracked at?
Yeah, well, I mean, I can give the canonical example, which is the sort of the seminal work by Joy Buolamwini and Tim Gebru on face recognition. And so they, in 2018, published a paper that says that face recognition is less accurate on people with darker skin and on women. This sort of, they ran an analysis of commercial face recognition software and did like a very in-depth study that shows that this is a consistent pattern. You could say anybody could have done this study, and there's some truth to that. But in practice, the people who did the study were two Black women, where this has been their experience consistently with AI technologies, that they have been under. I've read like this technology did not work well on them. And so this is, they were the ones who kind of conceived of this idea, like we should write a paper, we should expose this problem because this has been their experience. And it's not that the problem just appeared recently, it's been a while, it's just nobody has been asking this question. I think, from a personal perspective as well, I remember back when I was at Stanford, Pieter and I were in the same lab actually briefly at Stanford. And I don't know if you remember when we were working on the Stanford AI robot back in the day, and there was a language recognition system that was you could talk to the robot and would recognize you. That system did not recognize my voice. It recognized, I think, everybody else in the lab. Everybody else was male. Everybody else, they had different levels of accents, and the system still completely, essentially perfectly recognized them, and it just did not work on me. I would try to give a command to the robot, and it just had no idea what I was saying. It would just crash and burn. And so, now that I was a researcher on the team, I could ask the question of hold on, hello, what is happening here? Where's the system trained? And of course, it turned out it was trained on male voices. And there's a good chance that right now, I think a lot of these things have come to light. This may not be a surprise to the folks listening to this, that this kind of thing happened. But I think back in the day, 10 years ago, whenever this was, I don't think this was as obvious. This was us discovering this in the lab that oh, look, here's this pattern that's happening.
When you encountered that it wasn't listening to you, did that for you trigger, what did it make you feel? Did it change what you wanted to do research on? What was the effect?
So I'll be honest, I think the unfortunate part is that I was oh yeah, of course, I understand it's straight. I think I was, back then I was kind of desensitized to these kinds of things. I think I've experienced minor versions of that kind of throughout my career. And it was only much later that I actually started speaking out against it and being much more no, I got to change it. But I think back then I was just a starting PhD student. I was oh, that's okay. Don't worry about it. And I genuinely, I did not have a strong reaction. I think I've gotten built up a thick skin, which I think is, now it makes me really sad to say that, because I think if a first year student came to me and she said she has this reaction, I would have been no, that's not we got to change this. This is not okay. But I think it is actually, unfortunately, a fairly common reaction. You just kind of get used to these kinds of things, and you're just no, it's fine. I can't overreact. I should just play along. So yeah, maybe later it changed. I think all of these things over the years have kind of led me to this point now where I'm very passionate about the fairness research. I think we can and will do important things in that space. But it took me a while to get there.
I do remember actually back then, I think you were also the only female researcher in the lab.
Yep.
And that was normal. That it was almost special that there was even a female researcher in the lab. Maybe it wasn't even normal to have one. Mm-hmm. And that must have. I'm curious, how did you experience that? Is that also a thick-skinned thing and you just didn't even pay attention to it, or does it actually, how did that play out?
Yeah, so it's interesting. So I did switch labs later on in my PhD career. So I graduated from a different lab, which was largely related to my research interests just shifting. And then a new professor came to Stanford. So Fei Li came to Stanford when I was in my third year. And I always loved her work and was just really excited to go work in her lab. And so I ended up switching. I think looking back on it, I think in retrospect, I feel stronger about it than I did back then. I think back then I was oh, yeah, I kind of felt special, but also I think in retrospect, it was isolating and kind of lonely, I think, in ways that I hadn't realized until I joined the lab with more women. And it was oh, it's possible to have, you have different kinds of conversations, I think different kinds of connections when you're in a lab with people who are more like you. And then, gender, I think is part of it, but there's so many different dimensions. Just, I was oh, I connect with people on a different level in this lab, and that's kind of cool. But I think at the time I hadn't realized that that's something that is important. Like I remember I wasn't asking this question of like lab diversity when I was picking a PhD lab at all. Like it wasn't a thing that was on my mind, and it wasn't something that I had realized, until much later how important that actually is.
That's really sad that was a situation at the time, but it also sounds like it's something where a lot of people could be in the same situation as you were then, in that they've never experienced anything else and don't know there's something better out there. And so, and I know you've been spearheading a lot of efforts to increase the participation of any kind of backgrounds in AI. And so I'm really curious about, how you think about that and how we're going to be able to change that.
Yeah, so I a few years ago I co-founded a foundation called AI for All. So this was together with my PhD advisor Fei-Fei Li, and then with Dr. Rick Sommer, who is an expert in K-12 education. Sort of he's a mathematician, but has spent his whole career on the education side of things. And so we started this foundation to bring diversity into the leadership of AI. And we start pretty early. We're focusing on high school students. And we think about, can we identify high school students who have shown leadership potential? Leadership potential is sort of very broadly defined. This can be somebody who is, the president of a club at their high school, but it could also be somebody who has started a soup kitchen in their neighborhood, or it can also be somebody who has, taken care of their 4 younger siblings while their parents work. And it could be, somebody who's, has a black belt in karate in high school. Like all of these things are signs of leadership. Like these students are outstanding. They are going to go on to do great things. And we try to see if we can tell them more about AI, tell them about how AI can help solve some of the problems that they're passionate about. Generally, these students all have, particular things that are on their mind, whether it's related to their community or sort of world problems, or somewhere in between. So things like, ranging from world hunger, climate change, clean water in their community, cyberbullying, all kinds of things that are affecting them directly in different ways. And we try to help them see that, first of all, there are AI-based solutions to these problems. And we try to get them to see that, this kind of passion and their voices and their, excitement, right, and passion for these solutions are actually much needed in the field. Like we want to make sure all of these problems are solved with AI. And in order to do that, we want people like them to come in and help us diversify the type of problems we're working on, the type of solutions we're exploring. And so we try to show them basically a path into AI if they choose to take it.
So if maybe a parent or a student is listening to this, where did they go to find out more about this? Can they participate?
Yeah, absolutely. So it's so aiforall.org is the URL. So you can go apply to. We have different summer programs in partnership with different universities. So we have Stanford AI for All, Princeton AI for All, Berkeley AI for All. I think we're right now at 16 universities and growing. And so these are summer programs. They're pretty small. Each one is sort of 20 to 40 students or so. Where you can apply. They have different focus on different things. So, for example, the Princeton program is for AI technology and policy. So we talk about AI governance and how we develop both how we build AI systems, but also how we think about governing them. About what does it take to make sure that this technology is safe out in the world. And so you can apply to all of these different programs. There's sort of guidelines and age ranges and so forth. And then there's a number of other initiatives. So for example, Open Learning, which is our free online content for people who want to just learn a little bit about, sort of be introduced to this field without necessarily, committing to, a summer program of, a multi-week deep dive into it, but who just want to get a sense of kind of what's out there, how can we think about AI in the context of different problems in the world. And so that's AI for All Open Learning.
We are dropping new interviews every week, so subscribe to The Robot Brains on whichever platform you listen to your podcasts. When trying to reach people from diverse background, paying to go on a summer camp at Princeton, how is that handled?
So all of the camps are some just don't have tuition, and this is typically for the camps that are sort of day programs. So some of those are able to do this without tuition; they're completely free. And we try to be very thoughtful about the fact that many students will be working over the summer, and so actually, even if the camp is free, they still can't work. It's still a full-time program. And so they can't work during that time. So we try to sort of compensate for that by, first of all, providing food. So generally at all of these programs, there's sort of 3 meals a day. And we try to be very thoughtful about it's not pizza. It's nutritious meals that are substantial and have, that are good for you. Again, it's not pizza for 3 weeks straight. And we also provide, so from AI for All, from the National Foundation, we've also recently, especially kind of last year, the COVID times, we started providing additional subsidies and sort of stipends for students who attend these camps, even, again, the free camps, or who kind of need additional resources, either towards, they need to rent a laptop for this period, or they just, are missing out on income that they would otherwise have, and kind of compensating for that. And then all of the camps that have tuition. So for example, Stanford AI for All, Princeton AI for All, they have tuition. All of them need blind admissions. And for example, at Princeton, we actually explicitly say, if your, combined household income is less than a certain amount, this camp will be free. So you can apply, it'll be need blind admissions, but then afterwards, we sort of say, okay, can you submit, your sort of tax return from last year, or whatever, or even just write us a paragraph telling us about your financial situation. And we say, if it's below a certain amount, this camp will just be free, no questions asked. And this includes, we will, fly you out to the camp. We will pick you up at the airport. We'll just take care of everything starting from your flight until you come back home.
Wow. So I got to imagine you got some great stories of students who went through the camp, because you've been running it for a few years now. Can you maybe share a story or two of things some of the students have done?
Yeah, so we've got amazing students, and we have, there's just such a range. The clean water in the community that I sort of mentioned as something a student cares about. This is from a student who attended Stanford AI for All a few years ago, and she actually went and deployed an app and some AI-based solutions to sort of trying to solve the problem of water contamination in her hometown in Salinas, California. We have another student that won the Best Paper Award at the Machine Learning for Healthcare workshop at NeurIPS, at the top machine learning conference. So she went on to do some research at the Stanford AI lab, and actually was the lead author on this paper that was accepted to this workshop, and actually won the Best Paper Award around AI assisted healthcare. We've got a number of students who do an amazing job in the camps, and go on to do their own kind of outreach work, and kind of bring AI education to other students in their community who may not have access to this kind of program, who may not have gotten into these camps, or who might be too young, who might be in middle school. And they've launched AI clubs, but also things like AI and art initiatives to sort of run workshops around teaching younger students about AI technology through art. And there's just many more. I can keep going. There's just the students have been absolutely amazing, and they all come in with their unique perspectives and kind of unique viewpoints. And it's just working with them is kind of a breath of fresh air in many ways, because they just are passionate about different things, and each one kind of brings their own unique story to the table, and really wants to apply this technology for something that they are personally passionate about.
It's amazing to hear you talk about this with also so much passion. I think these students are really lucky, and I would strongly encourage any students hearing this to apply to AI for All. Seems like an amazing experience. Now, zooming out for a moment, that is one part. That is, you're educating AI leaders of the future early on, which is amazing. But can you maybe also give a little bit of perspective on, is that enough? Is that all we need to do? Is there more we need to do to get to the best outcomes? What are your thoughts on the overall picture?
One of the reasons why we started AI for All, besides summer camps, is the alumni community. So we're calling them change makers in AI, but this is essentially a lifelong community that we continue to provide support and opportunities to these students who attended the summer camp now a few years ago, but can we ensure that they can continue in this space? Can we continue creating community among them? Can we try to help them feel sort of supported and connected to other students who look like them, or who can support, who can relate to their experiences, and kind of create that peer community and also a mentor community. But going beyond AI for All students, I think there's a lot of conversations about diversity in the field, and in particular around demographic diversity. And I think that that's great, and that's very much needed. And there is less conversations around inclusion. So there is, so like you mentioned, right, there's a sense of oh, great, we got, a woman in the lab, but then there is comparatively, much less conversations around what does it mean to have people from different backgrounds? How do you, as the manager, as the professor in your lab, or, kind of as a leader of a group of people, how do you adjust your work style to actually, create a community that is welcoming and inclusive of all voices? How do you, I think one of the things that I've actually frequently heard and have, recently started speaking out against is sort of people who say, well, I treat all of my students the same, or I treat, all of my employees the same. And the thing is, what that really means is you treat them the way you yourself would want to be treated. But that does not work for everybody. That is going to likely work for students or people who are similar to you. That is how they want to be treated. But as soon as sort of you start working with people who are more and more different from you, the way you want to be treated is actually completely not the way that sort of works for them, or not the way that makes them more successful. And so, I do see there is an increase in conversations around inclusion, but I think still we are in many ways too focused on the demographic diversity numbers, and insufficiently focused on inclusion, on broader definitions of diversity. And, I hope that we kind of move more towards that in the coming years, while, obviously sort of the demographic diversity numbers are appalling. Like we need to do things about that, and we need to continue on that front for sure. But I think without the inclusion conversation, what's going to happen is exactly what's happening now with the leaky pipeline. We can bring diverse people in, and then they leave because of the way they're treated.
So as a professor myself, of course, I'm curious if you have any kind of specific tips on things that maybe you've done or seen other people do that really help with inclusion?
Yeah, I wish I had, great answers to this, but, one of the things that I started doing that I find it helps me, and I think it would be great at some point. I should, I've asked my students, I don't know how to ask this. Maybe once I have students who've graduated, they can sort of honestly tell me what they thought of this. But one of the things I do is I do a survey for every student in my lab, kind of every semester or so. They fill out a little Google form, kind of telling me about their goals, about what they've, feel like they've accomplished last semester, kind of do they feel like they've reached those goals, as well as, I specifically ask questions about inclusion. Are there things that kind of isn't working for them in the lab? I also have a separate, like, anonymous, this form obviously has their name because I want to know, if I ask them about what are your goals or accomplishments from last semester, whether you put your name on it or not, like, I will know who you are. But there's also, an opportunity to provide this anonymously. And again, it's hard for me to say whether this reveals, all issues, but I do find that I get very helpful feedback from that, just in terms of like random things I wouldn't have thought of, in terms, ranging from things like desk placement in the lab, where sort of, some students feel, more exposed in particular places and like want a more private location, to, the way like lab meetings are run, to whether they feel like their voices are heard, or maybe, they would like to be called on more often, or like sort of a whole wide range of things. And I find that really helpful. And again, it's very hard for me to say whether that addresses everything, or rather I'm 100% sure that it doesn't address everything. But at least doing this kind of like personal connection with every student, sort of personal check-in, I think helps me get a little bit of a better sense of what would work well in the lab, and sort of what's working and what isn't.
As I'm internalizing this, I'm kind of internalizing this as you're in some sense taking it yet one step further. You're not saying, I'm going to try to address this group or that group or that group. I'm going to try to find out for every individual in their own unique way, what is it that is going to matter to them, and hopefully, then be able to resolve whatever might need to be resolved.
Yeah, I think that's exactly right. And I also try to put my, PhD students in various like leadership roles in the lab as also kind of a way, in the spirit of more diverse teams bring better results, which has been shown time and time again. But also just in terms of like running the lab, if you put diverse people in charge of kind of different aspects of it, I think the end result ends up being more inclusive, just because it's not just sort of my viewpoint and my opinion, but kind of a more distributed leadership system.
I like that. Now, sometimes, I hear also the opposite, of course, is where underrepresented groups are asked to be taking charge on literally everything, everywhere, to check off the box that somebody diverse is helping out and in charge. And so, do you have any advice maybe on how to decline some of those things?
Well, I think my biggest advice is that if you're not a member of a minority group, you should be stepping up to do work for those groups. So, for example, like, just because you're not a minority, like, volunteer to order food or like organize, diverse in CS meetups, and that is very, very appreciated. And that's, one way to not take away like leadership roles from people who are frequently not asked to be in leadership roles, but you can take away sort of things that really nobody wants to do. Like, nobody wants to send out reminder emails about this meeting. Like, nobody wants to order food for these meetings. But if you can do things like that, that makes quite a big difference. And then, if you're a member of a minority group and you find, you're consistently being asked to serve on different things, I don't know if I have a great piece of advice. I relate as a woman, although, I think we've made much bigger strides in the gender issue than we have in race issues, for example, within computer science. But I very much relate. Like, I've served on panels where I was invited because I was a woman. It was very clear that like nobody really cared much what I had to say, and but they were proud that there was a woman sitting on stage. Like I've been in those roles, and yes, I also hear about the being invited to more to serve on many more committees. My solution to this has been, because of AI for All, like I care very much about AI for All, and I put a lot of time and a lot of effort into the work that we do there. And in some ways that helps me mitigate some of my guilt for saying no to other things. So frequently I'll sort of say I am already doing a lot in terms of service to the community. This is what I'm doing. I, send the link to AI for All, and I say, here's my role. Here's what I'm already doing. Like, no, thank you, can't take on more. But at the end of the day, it really comes down to you kind of have to yourself figure out where the boundaries are, and it's very unfortunate, but it is a much higher burden on people who are from groups that are less represented. Is that they do have the burden of kind of having to figure out where the boundaries are and what they can say no to, and how to navigate that.
Yeah, it's never easy to turn things down. It seems invitations tend to never be just invitations. They tend to come with expectations, and it's always a challenge to turn them down.
Indeed. Having some templates, also having a no committee, have a few people, and whenever an invitation comes in, you just forward it to them and say, should I do this, and have them vote, and then you could, make a decision from there.
One of the things I've always been curious about, as the ImageNet competition played such a big role in how AI and deep learning came of age, and you were one of the organizers of many editions of the competition. If you could say a bit more about the competition and what it was like from your perspective. And it's so interesting that you say, well, this team presented this like kind of out of left field solution. It was very different from anybody else. Nobody else was submitting deep learning solutions for image recognition to the competition, and they did. And it feels so complex at the time. And yet today, just a few years later, that feels simple. That feels like the natural way of doing things. It's changed things very, very quickly.
Yeah, for sure. It used to be, I remember we all sort of knew about deep learning. We all knew neural networks. We kind of knew it's a method, it's an algorithm that exists out there, but it just hadn't been applied on this scale. And certainly, I think, hadn't been applied with these kinds of groundbreaking results. Like, it was just so clear that this is an entirely new revolutionary approach to these problems. And so now, of course, in retrospect, now we say, oh, AlexNet, which was the system that won the challenge. We're like, oh, that's a simple baseline. We can run AlexNet, but really there's all these other networks that we're using, and it's also part of the undergrad curriculum. I spend in my undergrad computer vision course, I spend maybe a third of the course sort of teaching students about deep learning, because it's now a fundamental part of computer vision. How can you even teach an introductory computer vision course without deep learning?
And so the ImageNet competition is something that's such a iconic aspect of deep learning progress and AI progress. And as researchers, we all know perfectly ImageNet competition, what it is. But for somebody who's never heard of the ImageNet competition, what is it? What goes on in that competition?
Yeah, so it's a great question. So it's essentially a way to measure progress on visual recognition. So visual recognition, what we are referring to there is generally we're trying to build a system that can look at an image or a video, but in this case, an image, and understand what's in the image. So for example, look at this frame and say, okay, this is, a person sitting and there's also a chair. Or look at, a different picture and say, okay, there's a computer monitor and there's a keyboard. So kind of identify what are the visual concepts that are in the image. And so what we want to do is we want to measure how well one system performs in this task compared to another system. So in order to do that, what we do is we collect a set of images. So in the case of the ImageNet challenge, we're talking about 100,000 images. Some of the previous works have been, much smaller. You would collect maybe 10,000 images or so. You label all of the objects, and there are sort of all of the concepts that you're hoping the model would recognize. And so you evaluate, given 2 systems or given, 10 systems or however many, you kind of are able to then assign a level of accuracy to each system depending on how well it performs on this given collection of images, which is called a test set.
Can you say a bit more about what it means to be a test set?
Yeah, so a test set is basically a collection of a collection of data that is used to evaluate the performance of an algorithm. And the reason why you need a particular name for this is the test set is distinct from what's called the training set. When you're trying to compare the performance of different systems on a test set with known outputs, so the other factor, the other part of this is that these systems we're typically talking about a test set in the context of a machine learning system. So a machine learning system is essentially a system that learns patterns from data. So the way you're training, the way you are developing the system is you are showing it essentially a collection of, in this case, images with known outputs, and you're saying, okay, system, here you go. Here's a set of 1 million images. Some of these are images of cats, some of these are images of dogs, some of these are images of computer monitors. And so the job of the system is to extract patterns from this collection of data, and then be able to, given a new unseen image, replicate, sort of produce the right output there. And so this, for making comparison, comparing system 1 to system 2, one of the things that matters is not just comparing it on the same set of test images, but also making sure that these two systems have access to the same training data, so to the same collection of images that they are learning from. And so part of the ImageNet benchmark is both providing the training set that all of the systems are learning from, and then evaluating them on new unseen images, which are the test set. Yeah, so I remember back in 2012, so I wasn't yet an organizer, but I was sort of sitting in the audience watching the workshop, and kind of I remember watching this moment when this team got up to speak about their winning entry, and I was like, I don't really know why this model works. It seems really complicated, but it's so different than anything that's been submitted or tried before in this data. And it just works so much better. And I remember the whole audience kind of going quiet and sort of listening and go, oh, that, like, something is happening. Like, we're not really sure what it is yet, but something major is happening. And then over the next few years, just kind of watching this grow from, a small academic competition, we get some small number of entries. It was kind of, not nearly as big of a deal, to suddenly kind of ballooning in terms of, exploding in terms of number of submissions, in terms of media attention, in terms of sort of teams, academic, industrial, kind of all focused on this one benchmark. It was really kind of a magical or a strange moment in many ways, just kind of witnessing that.
So as an organizer of the competition, I got to imagine you had access to the test set and you could see results before anybody else. What was that like? Because you would see all these submissions come in, and then, it must be fascinating to know, like, weeks or maybe months before everybody else, how well the latest vision systems are doing on these test sets.
So honestly, what I mostly remember is sort of stressful things that were happening where, our server would suddenly go down when, near the deadline, or some team would sort of email us with, they submitted the wrong file, can they resubmit? And I feel like so much of my brain power was going towards mitigating those kinds of things that, I think at some point we would see the new numbers and be like, oh, cool, new number. All right, next crisis. So I think just managing this whole endeavor, there were so many details to keep track of that. We knew the numbers usually a week or two before the workshop when they would be announced, and that was exciting. But I think there was so much work to do during those 2 weeks that's mostly what we focused on.
Didn't really have time to enjoy it. You just had to get it done.
Yeah, exactly.
Yeah. So now, as you described, these vision systems are trained on a lot of data. And in fact, some people say data is the new oil, was a thing people said already many years ago, right? But that data, a lot of it, as I understand it, gets crowdsourced to be able to build the data set for ImageNet. Can you say a bit more about that process?
Yeah, absolutely. So the data that, so as I already mentioned, right, so the images need to have some kind of target labels on them. So for this challenge, right, the images were labeled with the objects in the image. And so in order to do that, you need people who are willing to look at, there's no automatic way of doing this. If there was, we would need to have the challenge. And so in order to actually get the labels, you need to have people sit down and actually look at every image and say, okay, here's what is in the image. And we need to provide, maybe we can automatically provide a guess for what is there. So we can say, okay, here's an image. We think this probably has a computer monitor. Is that true? Yes or no? And so this, so crowdsourcing actually enabled us to do this data collection at the scale of many millions of images, because as you can imagine, you have millions of images. It takes a person about 2 seconds or so to make a determination for whether a particular object is in the image. Now you need to do this you need to have many people look at each image to make sure your labels are accurate. And so, there was a back of the envelope calculation that we did at some point, which said, if we just have grad students or undergrads doing this would take something like 19 years of just like 24/7 labeling. And so being able to engage crowd workers and sort of parallelize this, engage a lot of people in the annotation process actually enabled us to do this at scale.
I think we kind of got through all the topics. Well, thank you, Olga.
Awesome. Thank you so much. This was so fun. This was really good. I've done podcasts before. This was by far my favorite. I don't know if it was like the questions that were just awesome or like the way you asked them or something. I don't know. I had a great time.